Welcome to this video, in a series on exploring Cimatron for mold design. We wish to thank you for your interest shown in Cimatron, and hope you will search out the rest of the videos in this series. Cimatron is software uniquely created for mold design, covering all aspects of the process. Cimatron speaks the language a mold designer understands by using the terms and definitions they work with every day. In this video, we will discuss importing part geometry, starting a mold design project, and analyzing the part for feasibility. We'll begin with importing part geometry. Cimatron supports standard part translators such as STEP, SAT, and IGs, as well as many direct translators. This includes individual part files, assemblies of files, and very often PMI notes. We will begin our design project by using the Mold Setup Wizard. Here we're going to give the project its name and decide where we're going to save it. Also, we're going to select a layout part, which determines whether it's a 1-cavity, 2-cavity, 4-cavity, or whatever the layout is. And we will select the units we wish to work in. Inside the mold design environment, the left side displays the tree that contains the assembly of components, and on the right side we can see the guide, which will take us through all the operations. We will focus our attention now on loading the part we're going to work with. This will be a single cavity tool. We will do multiple operations in this one step. The first thing we're going to do is make a working copy of the part. Once we have selected the part, we can apply a shrinkage factor based upon the material we're going to mold it from. And we will create another part to capture the mold shutoff surfaces, or a parting surface part. As this will be a large single cavity mold, we will position the part on mold center. Next, we will look at a feature called curvature map. We will use this to color code the rounds on the part so that we can graphically display them. We can customize the output we see by changing the range of values, or setting the colors as we wish them to appear. The output we see can be flipped from male to female side. Specific features can be tagged to draw emphasis to them, and that tag will stay with the part as it rotates. This information can then be published to a PDF file so that it can be shared with other engineers or with the customer. This brings us to our next feature, which is wall thickness analysis. We're going to measure all of the wall thicknesses individually throughout the part. We will calculate the wall thicknesses using sphere analysis, which creates spheres at each position to determine the largest possible sphere that will fit at that point. Again, the colors displayed can be configured to a range of values and colors of our own choosing. And just like curvature map, individual points we wish to highlight can be tagged. As each of these individual points is tagged, we can see the wall thickness changing with the geometry. And also, as we saw with curvature map, these results can be published to a PDF where they can be shared with other engineers or with the customer. Another nice feature we have is the dynamic clipping plane, which we can use to show a section through the part at any given point and at any given angle. We can change the display to get the results we want simply by dragging the slide bar. Our next analysis tool is used to get measurements. In addition to having nice tools for snapping quick linear measurements, such as from point to point or point to line, it will also measure angles. Angles between faces or edges. Find the radius of curves, individual curves or filleted surfaces. and it will give overall dimensions such as an overall XYZ box, and the mass and the overall volume of the part. All this information can then be published as an Excel file or a PDF report, making it very handy for quotation. It will even give you a nice little image of the part for the report. This brings us to our next feature: direction analysis. Based upon the part's current orientation, it will look for its primary pole direction, a secondary pole direction, and anything that it finds trapped or undercut in between. You can see how this is ideal for a quick mold analysis. Zooming in on the tabs on the underside of the part help us to see that it's identified those trapped areas that are going to require lifters. And once again, as we've seen with the other analysis tools, this information can be published to a PDF, which is invaluable in sharing with others. Thank you for reviewing this presentation. We invite you to look for our next presentation on the subject of Cimatron and mold design, which will focus on cavity and core separation by using QuickSplit.